Okay, let's talk about 10.3. And in 10.3, we are going to cover chords in circles more. So first things is the congruent corresponding chords theorem. And what that really means is says that in the same circle or in congruent circles, if two minor arcs are congruent, they are congruent if and only if their corresponding chords are also congruent. So what that means is if I draw a circle here, and if I had one chord here and another chord here, and somehow these chords are congruent here, these two chords are congruent, then we can be rest assured that the arcs on the outside, or this portion, are also congruent. Next is the perpendicular chord bisector theorem. In which says that in the diameter, if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord at its arc. So draw a circle here, and let's make this the diameter. It's going through the middle, and here's a chord. And if the diameter bisects the chord, that means they make a nice 90-degree or box. We can say that the chord itself is here and here bisected, so it's congruent on both sides of the diameter. Next is our perpendicular chord bisector. Our perpendicular chord bisector converse says the same thing but backwards. So it says if there is a perpendicular bisector, so there's a perpendicular bisector in the chord, and that happens to be a diameter, then we can say that perpendicular chord that is bisecting the other chord is the diameter. So here we start off with the circle. Here's a chord. It is being bisected by another chord. Well, we can definitely then say, hey, this chord right here, this purple chord, is the diameter. Go on to the next one. Our last theorem that we're going to cover is the equidistant chords theorem. Equidistant meaning same distant. Let's try to rewrite that. So they are the same distance. So in the same circle or in congruent circles, two chords that happen to be equidistant from the center, keyword center, if they are equidistant from the center, then they are the same length. Here, if there's a center here, and we have two chords, and they just happen to be the same length, like this chord is the same length as that, we can definitely say that the two chords are also congruent. So we can then say this is congruent to that. Let's try it out, okay? If BD equals 127 degrees, what is CD? So we know that they are both 8 and 8, so they are the same length. CD then has to be, so if this is 127, they also have to be 127. If BC now is 50 degrees, what is BD? Well, there's 3 segments here, so I can take 360 minus 50, that gives me 210. And the 2 segments left, the 2 arcs left, have to be the same. So I take 210 and I divide that by 2 because there's 2 of them, then they're both 105 degrees. So this would be 105 and this would be 105. Find X and Y. Okay, well, the wonderful thing about perpendicular bisects is everything is the same. X should then be 6 and Y should then be 75 degrees. Lastly, solve for X. Since we have perpendicular equidistant chords, I know those 2 segments have to be congruent, so 4x plus 1 must equal 2x plus 15. I'm going to 2x plus, I'm going to subtract 2x first. That gives me 2x plus 1 equals negative 15. Subtract 1, 2x equals negative 16. Oh, it's plus 15, I'm sorry. Plus 15, positive 15, minus 1 is 14. Divide by 2, x is then 7.